In this video I'm going to be talking about resolving forces. It's quite an important skill in mechanics that we are able to deal with forces in different directions and resolving them in two perpendicular directions. I'm going to start off with some simple examples with just singular forces, and basically it all boils down to trigonometry, but I suppose the key here in the longer run is to have quick and efficient ways of resolving in two perpendicular directions. But let's just start off with a few examples here. Let's just suppose we've got a force of 10 newtons and it's inclined at some angle here to, let's say that's horizontal along here. Let's say it's there at an angle 40 degrees, and we want to actually resolve it into the two bits which are going along this direction and along this direction, horizontally and vertically, if you like. Now, of course, this is just so-called Tower trigonometry, really, and what you'll see typically, the way this is explained is, well, we've got a right-angled triangle of forces here. Okay, that's 10 newtons, so we can just say that this component here, using so-called Tower, opposite over adjacent, because this is adjacent, this is opposite here, and this is hypotenuse. So we can say the component along here will be, and that's 10 newtons along there, will be 10 cos 40. And the component along here is 10 sine 40. Okay, that is how we resolve, just using right angle triangles. However, I want to just kind of skip over, find a kind of quick and efficient way of doing this without drawing kind of triangles left, right and centre, because as we'll see in later examples, it can get all a bit too much with too much going on to just be drawing triangles all everywhere. So let's just go back a step and just look, let's talk about the two components we need to split this along. Okay, well, the component along here, horizontal, that is going to be, the marked angle that we have is 40 degrees. So this would be on the adjacent of the triangle. So that's 40, that's 10 cos 40. So the other component, you can see there's like space here, if you like. There's kind of, the angle is marked kind of away from the component we're looking from, or opposite it, or away from it, if you like. It's not opposite because I'm not drawing my component here, I'm drawing it so that's all coming out to the same kind of point here. So then if it's away from the marked angle, there's nothing here, this kind of space, then this component is 10 sine 40. Okay, let's do another example. Of course, we can go in two different directions. So if we call this, we can call this direction positive this way and positive this way for the horizontal. Let's say this angle is now 35 degrees here. Well, I don't know, let's say it's 47 degrees. Just to try and make it more accurate, 47 degrees, and let's say this is 12 newtons, and I want to find the components in this direction and this direction. Well, the component in this direction, 47, that's good. I've marked the angle here, so that's next to the marked angle, 47 degrees, where I've drawn the arc. So this component will be 12 cos 47. Okay, now here I've got space here. There's kind of nothing there. So I'm away from the 47 degrees that I've marked. So when we have that situation, that's the sine. I'm just trying to get away without drawing the triangles, because of course if you drew the triangle would come actually, the triangle would come here. but I'm just trying to get away from that because with more complicated cases there can be too much going on and it can get a bit too messy. So that's 12 sine 47. Actually, in this case, because it's going downwards, it's minus 12 sine 47 because it's going downwards. Okay, and that's how to resolve in two different perpendicular directions. In this case, it was horizontal and vertical. But we will see lots of examples later where we're resolving in two other directions. For example, that you might have something on an inclined slope. Let's suppose this is this here is 8 newtons, the force there. Let's suppose we have an angle 30 degrees here. And what we want to do is actually resolve kind of the forces in these directions here. It's a bit messy, isn't it, with the... Okay, in these directions here. Maybe do it dotted, or just do a different colour just to get it. Let's do it in green. So that direction and that direction. Okay, as I say, you will see lots of this explained in other things with a vector triangle coming down here, which is fine. But as I say, in the longer run, I like to do it without actually drawing the triangle because the situations can get quite complex. So the angle there is 30 degrees. So this component here is 8 cos 30 because it's down the slope. It may well be that we're regarding this bit as positive here and this bit as positive here. So it might be minus 8 cos 30, but the main thing I'm worried about at this stage is getting the actual cos and sine the right way around. So that's minus 8 cos 30. And then, of course, this here, we've got space here. There's nothing there. There's no, the angle is marked here, 30 degrees. The angle is 30 degrees here. So this component will be 8 sine 30, going down the slope in this case. So we could say it's minus 8 sine 30. Okay, so that's a brief talk about how to resolve in two perpendicular directions. What might be quite good for you to do now, pause the tape, pause the video, and have a go at these and actually look at the actual different directions that we've got and draw basically the components. So in this case, the x direction that's 12 cos 20 because the angle is marked there, and this one, the y direction, is 12 sine 20 in that direction, whatever that is. Okay, so it might be a good idea at this stage, or I'll do the next one because this one's a bit obvious. The next one, x direction, there's no resolving to be done here, there's no triangle to be. So the x direction is 0 and the y direction is minus 5 because it's already going, the force is going vertically downwards. So that's that one. So if you just pause the video at this point, and then you could try and see if you get the other two in the right direction, whether you got the cos and sine the right way around, and whether you've got it, whether it's positive or negative the correct way around as well. So pause and then you can do that. Okay, so let's just look at this. Okay, the x direction in this case, let's do the x direction for each one of them first. Direction. In this case, we kind of got space here. The angle is marked away from that direction. So that's 8 sine 40. Whereas, but it's minus 8 because it's going in the negative x direction. So that's minus 8 sine 40. The y direction it's going upwards, and that's 8 cos 40. Obviously one of them is going to be sine and one of them is going to be cos, and it is positive in this case because it's going upwards. And then D, we've got the x direction is 10 cos 30, and it's positive because it's going in a positive x direction, and it's cos because I'm next to the angle I've marked there. And the y direction is 10 sine 30, but it's negative because it's going downwards. Let's write it out. Minus 10 sine 30. Negative because it's downwards, and sine because my angle is marked here, and I've got my component there which is away from the angle. Right, okay. E, again, let's look at the x direction first. It's cos this time because my angle is marked there, so I'm kind of next to my angle. So x direction is 6 cos 50, and the y direction, oh, but it's minus of course because it's going backwards, cos 50, and the y direction is minus 6 sine 30. Negative because it's downwards, and sine because of the space here, and I'm away from the angle that's been marked. And then finally, this one's like an algebraic one. Of course, you can work out these on your calculator, but often in work, we're not actually calculating these until we've done some other stuff. So we're not actually calculating them. So I've just left it out to save time using the calculator in this video. But this one is just algebraic anyway. That is f cos theta, and this is f sine theta, and they're both positive because this is going in a positive, that's positive direction, and that's positive as well, and that's f sine theta there. So that's the vertical, which is the y direction, and this is the horizontal. Okay, so in the next video what I'll be doing is actually combining forces. So here we're looking at, we've got more than one force, and as you can see, it'll be much better if we're not having to draw triangles left, right and centre in our work, if we actually can easily get the component for each force. But that'll be in the next video. So we'll leave it there and pass on to video number 2.